So you may recall from general chemistry that certain reactions are in equilibrium. So that's what this slide here is kind of describing to us, that addition and elimination reactions are equilibrating reactions, so therefore they are in a type of equilibrium. In this instance, these two reactions are temperature dependent. So when we looked at, when you looked at thermodynamics in a previous course, probably in general chemistry too, you were given this equation down here with the Gibbs free energy term being the sum of both an enthalpy term and an entropy term. So if you recall, the enthalpy term, that is generally calculated from bond breakage, bond formation, and you get this delta H value at the end, this change in enthalpy. The entropy term, right, that has to do with more of the disorder or the chaos involved in the reaction, and that term is always temperature dependent. So we're going to see that as temperature increases, we're going to get a larger entropy term. And then what effect will that have on the equilibrium of our reaction? So we see our double bond here for our alkene. We have an addition that occurs, and then this is our product here. Or if we have our H and our X over here on our product side, we can also use a certain reagent and have an elimination, and then we'll end up with our alkene. So let's take a look at the enthalpy term. So we see that just based on the numbers of, the energy for the bonds broken, after subtracting the energy that's released when the bonds are formed, we see that an addition reaction is favored, right? The enthalpy term is favorable. And we note also that sigma bonds are stronger, right? Because they have that like head-to-head overlap for sigma bond versus pi bonds we know are side-by-side overlap of p orbitals. So that's where these values kind of derive from, right? These sigma bonds or pi bonds, and we end up with an enthalpy favorable addition or for addition reactions. Addition reactions are not favored by the entropy term because we have, two things here, two reactants, and over here, our product is lower in entropy, right? We have a decrease in entropy because we go from two things to one thing, so things are more organized. So combining these conditions and these terms that we looked at, we can see that at lower temperatures, the enthalpy term will dominate, and therefore at low temperature, this top line here, we see that addition reactions will be favored, and then the opposite, at higher temperatures, the entropy term would be the dominant factor, and we'll see that eliminations are favored at higher temperatures. So the take-home message here, not so much the individual components of enthalpy and entropy that will need to be known, but you'll need to know that at lower temperature, addition reactions are favored, and then at higher temperatures, we would see a favorable conditions for eliminations.